Yep, go for it.
Hey everyone, how are y'all doing? Good night? Sleep well? No? Not so great? Come on in, come on in. So, my name's Tyler. I am going to give the talk on badge making. I'm not a professional PCB designer or electrical engineer or anything, but I do have a couple of badges I've put together, a couple of PCBs, put together some projects that I've done. So I figure I'd share my trials and tribulations with you and see if I can inspire some of y'all to build some of your own. So who am I? Like I said, I'm Tyler. I live in Huntsville, Alabama. I work for an IoT company doing smart lighting solutions. I do software development there. In my free time, I like doing CNC machine work, laser cutters, mills, stuff like that, and hobbyist PCB design. So just tiny little one-off projects, helping people with their stuff, and blinking lots and lots and lots of LEDs. So some of y'all have probably seen this term, badge life. It kind of originated with the DEF CON crowd. They started putting together conference badges, kind of like these, but with electronics on them, made out of printed circuit boards. They've ranged from just blinking lights on them to puzzles and games and interactivity and like connections and alternate reality games, and they just went crazy. People started doing a lot of really cool things with them in the last couple of years. And so it's been really exciting to see that kind of open up and become more accessible to everyone. So here's a couple of examples of some badge life going on. You can see all the different LEDs and different shapes. They're not your standard PCBs. You don't just get a green rectangle like you find in your computer. You get crazy shapes and colors and lights. Some of these have like screens on them and sensors and expansion ports, and all sorts of wild stuff. So some features that you'll find on a lot of badges, they're usually battery powered. You don't want to have to have an extension cable plugged into your badge while you're walking around and tripping people. Yeah, sure. I can probably get closer to the mic. Yeah, I'll have to drop down a little bit. Sometimes there's a lot of sensors.
Those badges that you just showed.
Yeah.
Are those individually made, or are they mass produced as membership badges?
It depends. Most of these are just kind of people like me who've just decided to design some badges and have fun. They're usually sent off to a fab to be made, so they're not handmade or anything like that. But yeah, they're usually made in pretty small quantities.
No, so those badges are created by a separate group, and they do about a small batch of 1,000 that they then hot drop in Las Vegas, and you kind of have to follow them on Twitter to find out where they are to buy them, because these are not like DEF CON regulated stuff. They just sell them freely. They don't do licensing and stuff like that, because if like you're a seller in Las Vegas, you can get in trouble for selling stuff and not paying taxes.
Yeah.
So it's very, DEF CON-ish, I guess.
Right, yeah. So a lot of these are just kind of like crowdsourced, kind of sort of just community-driven projects. But they do make the official conference badges too. And so when you go to DEF CON, you pay for your attendance. You do get a badge, and lately they've been electronic badges. So this is from this year's DEF CON. It had some sort of like NFC style communication on it, and it was battery powered, and it would hang from your neck.
I brought my DEF CON badge from 2 years ago, the one with the game that's built
Yeah.
into it. So
And
if anyone wants to see that, I can pull it out.
So there's a lot of different ways that people do badges. So
Compared to what it costs to come to PhreakNIC at DEF CON, it's hundreds of dollars.
yes, yeah,
for your
I
badge.
think it's $300.
Yeah,
Yep.
$240.
But there,
Every year it goes up.
yeah, and there are definitely cheaper badges.
And these badges are like $250. But they also get you into a party.
Yeah, there's a whole community around all that.
250 solder.
So it depends. Another big thing about the badges that has been really popular is that they're interactive. a badge that just kind of sits there and blinks is kind of neat, but if you can do something with it, that adds a lot of excitement around it. So a lot of them have games and puzzles, like mentioned, but some of them are just, they're hackable. They have ports exposed, and they have serial communications that you can terminal in on your computer and connect to it and send commands and start kind of playing with the badge, and that's always really exciting for people. And then, most importantly, pretty much has to have blinking lights. I'm not gonna say you have to, but you have to. So I kind of touched on this about the extension ports. So one thing that's happened pretty recently is they've kind of standardized on a protocol for extending onto badges. And they call this the Sword Art Online protocol, but no, it's the shitty add-on protocol. It provides you with a port that you can plug in tiny versions of badges into the ports, and it's like a pseudo standard. It's not fully operable, like you can't just connect anything to anything, but you can get close. And so most of the add-ons are just LEDs, don't have any like microcontrollers on them, but there are some that are pretty complex and start putting puzzles together when you start connecting different things to these ports. So I'm going to talk a little bit about the protocol. So the latest version of the protocol is the 1.69 bis. There are two versions. There's the 1.0 and then this one. 1.0 only had 4 pins. This adds 2 new pins, which kind of helps with the ruggedness of the connector and gives you a little bit to play with in terms of connectivity. So they'll have 2 connectors. One goes on the badge and one goes on the add-on. They connect. You've got 3-volt rail, you've got a ground pin, and then you've got I2C, SDA, SCL pins, and 2 GPIO pins that you can use for controlling lights, or you can use it to detect what kind of add-on you've plugged into your board. But that's basically all the protocol specifies, not much more than this. So don't expect everything just to work, but you can kind of at least know where your power and ground are coming from. You can light up lights and stuff like that. So the other part is they define which pins are which, so that you have these keyed connectors that have these little notches cut out of them, so you can't plug them in backwards. They're kind of hard to find. You can use regular pin headers and they'll work. It's a standard pitch width. But specifically these connectors are hard to find. Those you can find everywhere because they're used for cables to be plugged into like motherboards and stuff like that. Because this is not a cable, it's a connector, there's not often a whole lot of use for plugging in a board into another board like this. And so kind of harder to find. I'll give you some tips on where to search to find those, but don't worry if you can't find them. You can just use regular female pin headers and they will socket into that connector just fine. And feel free to stop me if you have any questions. I'm just gonna there's no real story to this presentation. It's just kind of things I've learned and things I've seen. And so if you see something and you want to ask a question about it, please do. So this is the badge I built for this year. My friend Dusty had a good idea. He was like, we should make a badge. And I was like, all right, what should it be? He's like, I don't know, pizza? And I was like, all right, we'll do it. And so we put together this badge right here. Looks like a pizza. It's got some LEDs on it. And we figured toppings would be a really cool way to use the SAO add-ons. So it can detect which toppings you have on there, and you know that having a pineapple on a pizza is illegal, so the board can explode or something like that. So we put that together. It didn't quite get finished in time, so I'll talk a little bit more about that, but it'll definitely be ready for next year if you want to play with a cool pizza board. So here's what it looks like. It's got the topping slots, it's got the battery on the back. And so it's using an ESP32, which is a Wi-Fi Bluetooth microcontroller. Pretty high power, but it's a very neat board. It has a lot of really cool features. Powered by a single AA battery. and I'll talk about some trials and tribulations for that part too. It has capacitive touch pads, so you can touch on the back of it, and that's what can do some sort of interactivity parts. So you can touch the different pads and do different things with that. And it's got 16 individually addressable RGB LEDs, which are amazing. They're so fun to play with. They're pretty cheap. They just add a whole lot. You can have regular LEDs and they light up and it's cool, but when you can really do like all the patterns and colors and stuff like that, adds a whole lot. And then it's got 3 of the SAO ports for the toppings. Or if you want to put your own SAO add-on, you can. It'll look kind of weird. It's kind of rotated in a weird way, so if you get like that little Pikachu add-on, it'll be sideways, but you know, why you put Pikachu on a pizza?
Anchovies.
Anchovies. I do have anchovy toppings. I'll show you some of the toppings we got. But yeah, basically the whole purpose of this talk. You can make your own. It's not too bad. You can start very simple. You can move on to super complex, but you can definitely do it. It's not too bad. You need a couple things to get started. So there's a couple of software tools that help you get off the ground. KiCad is my favorite EDA software, which is electronic design. So that's where you design your schematic, your PCBs, and that's where it will generate the files that you send off to a fabrication house, and they will make your boards for you. If you're using a microcontroller, I really like Arduino. It's really easy to pick up. They've got a ton of libraries. You don't have to write everything from scratch. And then for graphical design, you can use Inkscape. You can also use Adobe tools. I use Illustrator a lot. You can use Microsoft Paint. It doesn't really matter. It doesn't have to be vector design, but it just kind of helps keep things clean and manufacturable. You'll need a couple of hardware tools. These top 2 are the most important, a multimeter and a soldering iron. Even if you get the boards fully assembled and populated, you still need those 2. You need to test your board. There will be mistakes, especially when you're starting, new. And you will need to make tiny adjustments on your prototype boards that you make blue so you don't get them mixed up with the real boards. I had to run wires back and forth just to make modifications just to get the prototype working, and then I can order new boards that have those fixes built into the board. It helps if you have an oven, if you're doing any surface mount parts. You can do a lot of them by hand, but if you're making more than 10 boards, it really helps to have some sort of more machine-operated process to kind of help put those boards together.
Did you say oven?
Yes, so this is an IR reflow oven. So these are used to solder up boards with surface mount parts. So when you put parts on them, you put them on top of the solder paste, and then when it cooks in the oven, it melts down the solder, grabs some of the parts, kind of lines them up, and then it cools off, and you have your part built.
How is that different from a toaster oven?
This is a little bit easier. So this is the T962A, I believe. Is what the picture I grabbed. A toaster oven will work because all it does is heat up the board, melt the solder, cools it off.
You're gonna have to hack it a little bit first because you got to control the flow, the temperature
Yeah,
increases.
you got a door. You're watching the solder melt. You can open the door and close it.
All right. Well, I never thought about doing it manually like that.
Yeah. This helps a lot. It's press a button and go, and it just kind of works. You can get these for like $200, $300.
You said it's IR?
Yes.
Infrared?
Yeah. That's the common oven type. There are some convection ovens and stuff like that, but the IR ones are really cheap, pretty accessible. So your most important tool is time. So that's kind of why the pizza isn't ready this time. I gave myself a couple of months to put the pizzas together, and that's not enough. So you want to be preparing very early, especially if it's more complex. If it's simple and just has some LEDs, even then you want to give yourself more time. But especially if it has a lot of parts and a lot of unknowns. So things that contribute to time are ordering boards. If you order a set of prototype boards, it might take a couple of weeks to get your boards in. Then you get them in, you build up your prototypes, you test them, you start trying to figure out debugging what's going wrong, and then you have to order more boards. So it's very rarely a one-time order a bunch of boards and be done. You always want to order a small batch and then test those and then order the full batch so that you can make any changes you need to make. So here's the checklist. Don't worry if you can't read it. It's that goose causing problems. But basically, this is why it takes so much time, because there's a lot of things that you don't know what's going on. So on this list, I've got, you put your rough sketch, your feature list for your board. You select a microcontroller if you're putting one of those on there. You put together your power budget. We'll talk about that. You design your power supply. You capture the schematic. You map the parts. You place and route the parts. You draw the board outline so that it cuts out properly on the router. You do your silk screen and visual adjustments. You order the prototypes. You test the prototypes. You make your PCB fixes. You write your software. You build all of the boards and put it all together. Sometimes you do a lot of these steps over and over again. So like really, you want to have that time. So don't try to wait too long. If it's coming close and you haven't started yet, go ahead and start, but plan for the next time. Don't try to rush it. It's usually not fun. So I'm going to talk about power budget a little bit. So these are battery powered devices. So you have to consider a lot of things. You got to consider all the parts that are going on the board so that you can extend your battery life. If you're doing something that's plugged in, you don't have to worry about this as much. But for badges, that's very important. So consider all the parts on your board, all the LEDs, microcontrollers, sensors, whatever else you have on there. Go to the data sheets, see how much power they draw, add it all up. It adds up very quickly. Even small things like LEDs, little sensors, little flash chips, it adds up. So go ahead and count all of those things. Consider the sleep modes of your chips. So microcontrollers have a lot of sleep mode characteristics. Sensors often have sleep mode options, or sometimes they just go into idle and go into sleep mode. And with that, you need to consider your duty cycle. So when you have a board that is using like a microcontroller for like this, most of the time it's going to be asleep. It's going to wake up whenever it needs to do something. It's going to wake up when someone's interacting with it. It's going to wake up on a timer every 5 seconds, wake up to blink, stuff like that. You need to take that into account when you're trying to figure out how much power does this device use. And then you have to determine what your expected lifetime is. So if you're doing this for a 2 or 3 day con, maybe 4 days is long enough. Don't try to make it last a year. You're just over complicating the problem there, and you're probably missing out on a lot of cool interactivity pieces of the board. When designing a power supply, there's some helpful tools out there. So like I said, you can do this. You don't have to be an electrical engineer to do all this. Texas Instruments has a tool called WebBench, and it can help you build a power supply, which is one of the most annoying pieces of electrical engineering that you ever have to interact with. And it does it for you, so that's great. You put in what input voltages you're going to get and what output voltage you expect to get and what sort of current draw you need. And it will go pick some parts and put together a schematic for you. It'll even do a little bit of the PCB design layout and provide you the bill of materials saying you need this chip and these capacitors and these inductors. Just put them here and you'll have a power supply. This hasn't failed me yet. I've used it to build 4 or 5 power supplies. It's been really nice. It tells you exactly how much it's going to cost, exactly how much room it will take on the board, and it'll tell you like what the efficiency of that power supply is. So on the pizzas, for example, it has that one AA battery, and that's 1.5 volts. The LEDs on the board need 5 volts, so I had to boost that 1.5 up to 5. Drop that in here, got a circuit built. Works great. Highly recommend this tool. All right, so on to some more artistic parts of the board. So PCBs are designed in layers, like an onion or an ogre. The middle layer right here is the fiberglass. So this is the non-conductive substrate that the whole PCB kind of sits on. It's got kind of a yellowish tint. I'm going to pass out some sample boards that y'all can keep. We'll go over some of the colors. I'll actually go ahead and do that so y'all can look at them while I'm talking. Let's see. Open one. Somewhere. Let's pass this one out. Just pass these around. Take a couple. You can keep these. These are going to be handy if you go design a board. It'll kind of show off some of the color mechanisms. So when you're designing things for like digital art, you usually have all the colors that you can show on your screen or on your printer. On a PCB, you're much more limited by the manufacturing process. Got to pass more out this side. I think that should be enough. If you don't get one, just let me know. Grab them. So, like I said, the middle layer is the fiberglass, semi-translucent. It's a yellowish, greenish color usually. Sometimes it's a beige color. But on either side of that is the copper traces. So when you're designing your PCB, anywhere you can put copper lines or fills, that will be on top of the fiberglass layer. Above that is the solder mask. So the solder mask is what gives PCBs that green color. There's usually a couple of different colors you can choose from. So the one I'm passing around is a blue solder mask. The pizzas used a yellow solder mask. They have red and purple and black and white and green and just a couple of different options. It's not infinite, but you usually have 7 options that you can pick from. And then on top of that is the silkscreen layer. So usually you only get 1 or 2 options per color on that. Usually get white, like on the boards that are in your hands. On white PCBs, you usually get a black color, like on this one. Sometimes you can ask for black on a blue PCB. Some places will do it, some places won't. Another reason why you start ahead of time so that you can ask these questions and find a manufacturer that will give you what you want. So the thing you got in your hand is my little color swatch I put together just to kind of show off the different mechanisms for generating color with such limited color options. So on the far right, on that side, you have exposed copper plating. And so that actually is a gold-plated material. Whenever you don't have solder mask, but you do have copper, that's how that will show up. So you can get that really shiny gold color. If you're doing gold plating, you get a really shiny silver color if you're doing the solder plating. I'll go into a little bit of that later. Moving our way left, that's the exposed fiberglass. It's exposed on both sides, so you can see kind of how translucent it is if you hold it up to the light. It lets light through. It's kind of got that sort of soft edge where you can see the shadow from the rest of the board coming in on it. But yeah, it gives you that sort of color, that sort of beige color. Sometimes you have to be careful because sometimes that fiberglass layer actually has printing on it. Just depends on where they get their fiberglass substrate from. But it's a color people don't consider when they're making PCBs. They always think solder mask and the silkscreen. To the left of that is there's solder mask and copper. So there's copper underneath the solder mask, and it sort of lightens up the solder mask. You can kind of see a difference in color there. So if you're looking at like a standard green computer PCB, you can see the traces under the green solder mask, and you can kind of tell the 2 color differences. And so that's with copper under it. Further left, it's without copper under it. You can get that darker color because there's nothing reflecting light back up from the metallic underneath. And then the other 3 are just kind of some sort of little patterns you can see that you can kind of do a little bit of dithering, but it's not, you can't really do true halftone design, but you can kind of give the effect of a gradient. And then on the back, you kind of have some other colors that kind of pop up that are even more, a little harder to think about. But you kind of get that green, red, and yellow versions of the fiberglass. And that's because the green is where there's solder mask on the back of the board. And that's kind of showing some of the blue through the fiberglass. And the red one is where the copper is kind of showing through the back of the board. So there's a lot of really cool color options that you can build just using the different layers that the board is made from. Does anyone have any questions about that? No, that's kind of weird.
Is the hole on the left just a giant gap?
That one is actually, I think, routed out. I think that's, I don't remember if that's a drill.
Through.
Yeah, what?
Bladed through.
Oh yeah, that's true. That is, it's bladed. Yeah, so I think it is just a big via. It's just a big hole. Yep. It's crazy what you can send to these. Yeah, you can send these to fabs and they'll make it. You know, they didn't ask any questions about this. Like, why are you, this isn't a circuit board. Why are you doing this? They don't really care. They don't check.
They want money.
It does say PCB color, doesn't it? You're paying the money. It's just as well.
Are these 3 different types of fiberglass? Is that what's on?
No, for the 3 different colors?
Yeah.
No, it's just it's whatever's on the back of the board shining through.
Okay.
So yeah, the middle one's got the copper shining through on the back. The left one's got the solder mask shining through on the back. So it looks like they're different colors of fiberglass because the fiberglass is kind of see-through. But yeah, no, all the same. Yeah, please. And if you want more, I've got plenty. I made them just to give out so people can see them and have them in hand when they're designing their own board, and they can be like, okay, how's this going to look? How's this going to show up?
You're gonna have a lot of people contacting you.
I hope so.
I need help.
I hope so. So, like I said, you can get different plating on the pads and exposed copper pieces. On the left, this is PhreakNIC, which is electro nickel immersion gold electro. I don't know. It's gold plating. If you say gold plating, they'll know what you mean. But it's ENIG. And that gives you that rich gold color on the pads. It's really handy for storing boards for a long time. That's why it was designed, so that you can have PCBs sitting in a warehouse and then you can just pop it out and assemble it. The others tend to corrode with moisture over time, so that's why they kind of designed this process. Makes soldering a little bit easier. But on the right is Hassel, which is the hot air solder leveling. That gives you that sort of silver color. And so depending on what your board is, you can use either. Once you solder pieces onto here, it's going to be the same silver color. So keep that in mind as you're putting parts on a board. If you are using just regular pads and holes, once you solder them up, you're not going to see that gold color. So you need to make sure if you're trying to get that gold effect to leave those exposed and don't solder on them. So this is sort of the process I use to do the visual aspects. I usually start with the board outline and work my way through the different layers. So this is a shape that will be evident very shortly. I'm sure most of you have drawn the shape in your life and don't know it. So you start with the shape. It can be an image, it can be a vector image. It doesn't really matter. KiCad has an option where you can import images and then it'll create parts for you. So you can't really see in that third picture, but that's the board outline imported into KiCad. And then that's the 3D rendering of the board cutout.
What software you said? PCAD?
KiCad,
KiCad, yes.
K-I-C-A-D. Yep. Yeah, KiCad's open source PCB design software. It's free. It's currently being bankrolled by CERN, who made the Large Hadron Collider research group. So very cool organization keeping that project afloat. So after you get the board outline, you can start playing with the copper layers and the silkscreen layers, whatever else. Same exact process. You load in an image, you run it through the little bitmap converter, you drop the part on the board, and then you get whatever whatever you're trying to do. You can, so this is using the silk screen, using the white silk screen. You can also use the solder mask if you want to do a different color. You can use the copper plating if you want it to show through that way. Just whatever you need to do to make your design work. So who here has not drawn this in like middle school?
I'm too old.
2, 3? No, you never do the little S where you draw the lines.
I'm not aware of it. Yeah, aware of it.
So selecting parts, got some tips here. Consider your part technology. So there's surface mount technology and through-hole technologies. Through-hole is sort of like the old school, like you have a resistor and it's got wires and you bend them, put them through holes, and you solder the other side. Those are really easy to do by hand. They're not great if you want to make 1,000 boards, just because you can't really automate that process very well. It takes a lot of time to bend the leads and put them through the holes and solder the back side, flip it over and all that stuff. But
Sell it as a kit.
Yeah.
Have them solder their own stuff.
you can do that, and that's a big plus there, is if you're making a fairly simple board and you want people to assemble it themselves, that's really popular. And yeah, you usually want to use through-hole parts for that just because it's a lot easier to put together by hand. Surface mount, you get a lot smaller parts, a lot cheaper parts, a lot more manufacturable pieces, but again, a lot harder to debug and test and put together and prototype, but it can be done. Consider the size of your parts. You can use really, really tiny resistors and cram a bunch of stuff onto your board, but it makes it harder to manufacture. If you're using tiny parts that have tiny pins that are underneath the board, that just, you can't put together with a soldering iron, it makes it really hard to reliably manufacture it yourself. It even makes it a little bit harder for fabrication houses to manufacture and assemble boards. But makes your board smaller. Means you can put more things on it. So there's a balance there. Just something to consider when you're picking your parts. And then most importantly, cost. That's a big driver of what we do. This is all a hobby for most of us, so we can't afford to make $150 badges every time. Especially when you want to make 100 of them so you can give them out at a conference or sell them at a conference or something. And then the number of parts. It's a big difference having a badge that has a resistor and an LED on it versus one that has 16 RGB LEDs and a microcontroller, 2 power supplies, and 3 add-on ports and an I2C multiplexer and stuff like that. Adds up pretty quick. Every little part you add on there just makes it more complicated to put together, so keep that in mind. So these are a couple places I buy parts from. Mouser and DigiKey on the left. Those are in the US. They're very reliable, getting parts to you very quickly. Very good search mechanisms. Sometimes for connectors, I go to eBay. It's kind of weird, but there's a lot of Chinese sellers on eBay that have a very inexpensive connector selection. But it's a lot less reliable. So if you're making one batch of boards, you can go to eBay and grab them. But if you want to use a connector that you can rely on and wait and use in a later board, you probably want something else.
Don't buy FTDI from eBay.
Don't buy FTDI chips on eBay. They're usually clones, almost always clones.
What kind of chips?
FTDI. It's a brand that makes serial adapters, and they've had.
And they were pirated. The
Yeah.
FTDI chips are good. The
Yep.
pirated ones are bad.
And on eBay you can't tell which is which. They look exactly the same, and FTDI started cracking down and actually breaking.
Suspiciously cheap.
Yep. Yeah. If it's less than $4, it's probably not an FTDI chip. Another good source I've found recently is LCSC. They're sort of more like Mouser and DigiKey, but they're based out of China, I believe. They have a lot of parts that you can't buy on Mouser and DigiKey, like NeoPixels, for example, the RGB LEDs. They have those on LCSC. And it's a little bit more reliable than eBay, but they're pretty cheap.
Is there a reason why you don't have an Alibaba on there?
No, not exactly. I use it kind of in the same spot that I use eBay when you're trying to find particularly connectors. It's really useful. But again, it's kind of hard to rely on a vendor from like AliExpress, stuff like that, because they don't provide as much information usually with like data sheets and models and footprints and stuff like that. But eBay's usually a little bit easier to get started with. AliExpress kind of got some weird payment options and stuff like that. I think they use PayPal now, but for a while you had to use like specifically a Visa credit card and not a debit card, or some kind of weird things to get payment through. But no, AliExpress, Alibaba are good sources for a lot of those parts too. So for manufacturing the boards, just getting the boards printed and cut, there are a couple of options. I've used smart prototyping a lot. They can do fairly inexpensive boards. They have a lot of solder mask color options. They're the ones who made the pizza boards, so if you want to see what kind of quality they put out, you can come look at these boards. Actually, they made the boards that are in your hand too. They have, yeah, like I said, a couple solder mask color options. They have blue, green, yellow, red, purple, black, matte black, white. So pretty much the standard selection of colors. A neat thing about them is they let me put the black solder mask on the yellow PCB, which is not super common. JLC PCB did not let me do that. They have very strict, no, this is how our boards are made, this is how you do it, no substitutions. But JLC PCB is a little bit cheaper, and they have a couple of options. They're actually run by the same parent company as LCSC, so you can kind of order parts and PCBs at the same time, which is kind of a nice thing. And they just recently started doing board assembly, so you can actually order the parts, order the board, have them put them together, ship them to you fairly inexpensively. But I think they only do green PCBs and parts on one side, some restrictions there. So I haven't tried it out yet, but I'm excited to. Smart prototyping will do part assembly if you ship them parts or give them a list of parts to go buy. But that's usually for much larger scale things. And then for prototypes, I like to use Oshpark. They're in the States, and they have one color option. It's the purple board. So it's usually if you see someone with a purple board, it probably came from Oshpark, and they only do the gold plating. But they'll let you order 3 copies of a design for a couple of bucks. Get it sent out to you in a couple of weeks, and it's very good for testing out designs without having to order 100 or 500 or 1,000 boards, and then finding out you have a mistake on the board.
Just to add something, OSH is open source hardware, and on their website you can find other people's designs, and they welcome you to buy their designs, and it's shared among the community. And there's a lot of little add-on printed circuit boards on their website.
Yeah, they're a great
Super
company.
cheap.
I highly recommend them. They've done a lot for the community.
I think it's $4 per square inch.
Okay, yeah, not expensive at all. The others tend to price things in brackets. So if something is 5 centimeters by 5 centimeters or smaller, it's one price. Once you move up to the next size board, which is 10 by 10, it's another price. Once you move up to the next one, 15 by 15, it's a different price. But yeah, Oshpark does do the per square inch. So if you have a really tiny design, it's super cheap to send it off to Oshpark. So that's all I've got on slides. Do you have any questions?
So when you, like say you're gonna print out a batch, would it be more cost effective to do a bigger board and then do your design across that board so then you just punch it out when you get it, or just say, okay, hey, I know it's this dimensions, just send it out and say I want this number?
So it depends. The different PCB manufacturers have different rules. They call it panelization. So that's putting one design in a big panel, shipping that panel out to you, and then you punch it out, or it's mostly cut out and you can break it away, stuff like that. They have a couple of restrictions on how you can panelize boards. Some of them only do it where you can use, there's a V-score bit that they use that lets you just kind of snap the board. It doesn't leave a nice clean finish, and if you're doing an irregular shape, that doesn't really work so well. But some of them will let you route out the whole board design, except just leave a couple of little attachment points that you can break off. And it can be cheaper. If you're making a lot of small things, it can make it a lot easier to assemble them because you can put solder paste on all the pads of all the small things in one big board chunk and then make 20 copies of a board at once instead of having to assemble a tiny little pepperoni piece like on these. But the drawback there is that you don't get nice clean edges around your boards. So if you've ever had a piece of electronics that's had sort of like a little piece that kind of sticks out that's a little sharp, but yeah, it looks like a little like 3, that's because they panelized it. If you don't panelize it, you get nice routed edges that are really smooth. You can't really cut your hands. So it's kind of a trade-off there that you can do. For me, I've never really found it useful enough, just because parts tend to get cheaper when they get smaller, and parts tend to get cheaper when you scale up the number. So if you are ordering 10 boards, it costs this much. If you're ordering 100 boards, it only costs a little bit more. So it can usually, kind of negate any savings you get there.
Okay. When you order your boards, do you have to specifically tell them you want, like if you're doing surface solder mount, do you have to specifically tell the manufacturers, I want a solder stencil
Yes.
included?
Yeah, so I don't have any of my stencils here, but those are used for putting together the surface mount parts onto PCBs. It's basically a stainless steel sheet or a mylar sheet with little holes cut out of it with a laser cutter. That lets you squeegee solder paste onto the boards, drop your parts on, and throw them in the IR oven and cook it that way. All 3 of these companies, well, the top 2 will definitely manufacture a stencil for you. They use stainless steel. Oshpark has a sister company that I think it's called Osh Stencil, and they'll give you stainless steel or the little mylar sheets for just a little bit extra cost. But yeah, those are super helpful for putting together a lot of boards.
Now, have you done pick aparts or pick and place with any of the manufacturers yet?
I've done that with smart prototyping. I've had some boards assembled by them. It's pretty complex if you're doing just a few. Smart prototyping, they start if you want to use their pick and place machine to put boards together. You have to have an $800 minimum order for assembly. That's the sort of base cost for that, because it takes them a lot of work and cycles to put the program together and load up the reels and get it all working.
Have you heard of MacroFab?
I'm not used to that.
So they're like a small batch pick parts.
Okay.
So they have a list of all the parts that they have that sit in their reels, and if you use their parts, it actually becomes cheaper than if you say I want these specific parts. They'll be
Yeah.
like, well, now we have to get the reels for these,
Right.
so how about you just use our parts?
Yeah.
So they have a list of parts, and if you build it all with theirs, then they'll do the pick and part for the whole damn thing.
Okay.
And
Yeah, that's
they're-
kind of what GLC PCB has just started doing.
Yeah.
It's like if you use their parts, they'll assemble a board for you. It's a lot cheaper.
Yeah, so I noticed like if you're doing a small count, it's more expensive per board, but the more you ramp it up, it's like all of a sudden the cost per part starts
Yeah.
dropping drastically, but
And-
then you're spending thousands of
Yeah.
dollars.
Yeah, and that's an easy trap to fall into is when you start making these PCBs. You'll want to order a small batch of like 10 boards, for example, just because that's sort of like usually your minimum order quantity, unless you use like Oshpark. And it'll be maybe $20 to order 10 boards. And then you'll see that little slider and you'll drag it up to 100 boards and it'll be like $25. You're like, I might as well just order 100 boards, right? I probably did it right. And then you drag that slider up to 500 boards and it's only like $40. You're like, oh, but it's 5 times as many boards. And you can just sit there and drag that slider over and over and over again. Before you know it, you're spending $600 on PCBs that,
Don't work.
That need a jumper wire.
Right, yeah, they need a jumper wire. So you gotta be careful. That happens with the boards, that happens with the parts, the components. When you're buying on Mouser, you buy one part, it's 10 cents. If you buy 100 parts, they're a cent a piece. So it's very easy to start picking up all these things and you have bags and bags of resistors that you don't need and stuff like that. So
easy.
yeah, it's so easy. You just gotta be careful. Gotta be a little diligent about that.
You mentioned W bench or web bench.
Yeah, web bench.
What's
That's Texas Instruments. That's TI's website. Yeah, the Webbench Power Designer. Super useful tool. Highly recommend it. It uses TI parts, so just keep that in mind. That's what it's here for. It's to sell more of their parts, but it relieves you of a lot of mystery and unknown with electrical engineering design.
That could be an easy button for your power.
Yep, it's such an easy button. And this one generated, I think, 17 different power supply designs that I could have picked for these
Now,
parameters.
will it let you dump that straight into KiCad or KiCad? Or do you have to recreate this in KiCad?
I have recreated it. I know there are some outputs for
Okay.
EDA tools. I don't know exactly what they are.
All right.
But they're usually small enough. It's only a couple parts that I just rebuilt it in KiCad. I did look at their PCB layout output and sort of based my design off that, just because inductors have to be really close to the pads and all of this stuff. Usually it doesn't matter a whole lot, but just try to match what they give you, because this should work.
So we looked at the shitty add-on, I got a call a while back, and while it's pretty clear, if you're making the main badge and you're making the add-on, you can do cool things with GPIOs and digitals. But if you're just making an add-on, is there any sort of convention? I mean, is there a timing signal on GPIO 1 that you should be paying attention
Right.
to, or anything you should do to try to?
It's really not a standard. I call it a pseudo standard. The things that you can rely on are power and ground. You do have those two I2C pins, but even I2C being a protocol doesn't tell you anything about the data that's being sent. So there's really not a whole lot out there standards-wise. So maybe that'll change over the next couple of years. Maybe a group of aspiring hackers can start to agree on some stuff, organize, revolt. But there's really not a whole lot of reliability there. You get power and ground, and that's the big thing. Unless, like you said, you're doing both sides. So on the pizza boards, there's an EEPROM on each of the toppings that identifies what the topping is, and the board is designed to go read that so that you can see which port has which topping in it. Like I said, just yell at you if you put pineapple on there, even if it is the neatest looking topping.
All right, now you said EEPROM, now how big?
Uh,
What is the data?
I want to say these were 2K EEPROMs.
That's a lot of
Yeah,
data.
you can put whatever you want on there. That was why I was excited. You can identify parts using just a couple resistors and measure the voltage across them. But the EEPROM, yeah. I was
Where the
like,
pineapple was grown? how
right,
big,
exactly. How many boards that pineapple has been plugged into.
So what is the interaction when you plug in a pineapple? Does the light on the top just go nuts? Or?
Right now, it doesn't do much of anything.
Okay.
Yeah, but the idea of these boards is that they've got Wi-Fi, and so we were going to build a couple of different puzzles and games for you to play on
Okay.
the board, and then there's going to be a leaderboard where if you passed the sort of gates in the games, you would upload your score up to like a leaderboard, and your avatar would be your selection of toppings that you put on the board, so that you could kind of be like, oh, that's the guy with all the pineapples on his pizza. Why is he eating first? What the heck? Just kind of like a silly little thing there. But yeah, it's mostly visual.
Okay.
But if the boards they'll be open sourced, and the software will be available, and so people can do whatever they want with them.
How much are you looking to sell those for at DEF CON?
Probably $45. Not very expensive. A lot of the DEF CON badges go, like you said, for like $200. But these will come in a nice little silk screened tiny pizza box. You open it up, it's got a little pizza logo. This one, just a couple little fun things. It's just neat what you can do with the tools available to you these days. Anything else?
What's your favorite medium to be contacted on?
You can reach me on Twitter at Tyler Crumpton. That's probably the easiest one. You can also email me, tylercrumpton@gmail.com. If you come to me afterward, I can write that down and put it anywhere in the slides. But yeah, if you have any questions about PCB design, please let me know, and I can help you get through your first one, especially if you get stuck in somewhere with the electronic design part from KiCad, or trying to figure out how to get some of these color options that are on the little swatches. It's a lot to sort of think about when you're in the design tool, like multi-layers, because the design tool is just a flat 2D design, and so when you're trying to figure out how to get these different colors, it can be kind of hard to wrap your head around it, which is why I made these, so that I could just have it in my hand and see them and go, this is how you get this color. Did everyone get the color swatches? If you didn't get one, please come up and grab one afterward. Take a look. Anything else?
You double E?
I'm a computer engineer, so a little bit of double E, but mostly software. So I had a little bit of electrical design background in college, but most of this I learned just from doing it, just having fun. Hence why I don't design my own power supplies. Just let the tool do it for me. But yeah, yep. You don't have to be a double E. All right. Thanks, y'all.